Okay, so in this video, what we're going to do is we're going to try to figure out if triangles are congruent, but we are going to put our thoughts down into what's known as a proof, or AKA a flow chart. Okay, and so a flow chart, basically you need two things. You need a statement, okay, and once you make your statement, we're going to put that in a bubble, and underneath your statement, we're going to come up with the reason. And your statement and your reason is going to lead to something else. So statement and reason leads to something else. Okay, now that's something else. A couple things can lead to that overall thing. Okay, so that's what we're going to be working on today when we look at our proofs. So here's our first one. We are going to prove that these two triangles are congruent. So the first thing that I'm going to do is I'm going to ask myself, do I think it is one of the 5 triangle proofs that we have seen before, and then hypotenuse leg. Okay, so I see an angle, and I see the side in between, right? And same thing on my other ones. So it is safe to say that it's going to be AAS. Okay, so now we know why this is true, and basically we want to put it all together. Okay, so what's the first piece of information? So we have to have an angle that's congruent. So remember that little arcs tell us that angles are congruent. So I can see that A and D both have one arc. So what I'm going to say is I'm going to say that angle A is congruent to angle D. And I get to say this because, again, the arcs were given to us. We didn't have to do any work. So I'm going to put the word given underneath. So I have my first angle. My second angle has 2 arcs, and that's angle C and angle F. So angle C and angle F, so I get to put that statement down. And again, why do I get to say that? It's given information. And then finally, I can say that my line segment BC is congruent to my line segment EF. And remember, the order of your line segments doesn't matter. It's what your angles do matter, right? And why do I get to say that? Again, given information, because there's a little tick mark. So again, here's my angle, here's my angle, here's my side. All 3 of these things, I'm going to draw an arrow, they're leading to our conclusion. So here's my conclusion. What were we trying to prove? We were trying to prove that these 2 triangles were actually congruent. And they were, based on our reasoning, AAS congruency. Okay, so let's try another one. Again, you can pause the video and you can try thinking of why these triangles are congruent. Again, we have our SSS, our SAS, ASA, ASA, AAS, and hypotenuse leg to think of. Okay, so I see 2 sides in common, so I'm looking at these 2. And then I do see LM in common. And so if I broke these up into 2 triangles, LM is in both the triangles. So it's safe to say that this one is going to be SSS. Okay, so the first thing I'm going to do is my first side. So I'll do 1 tick mark. So I'm going to say LK is congruent to LN. And why do I get to say that? Again, it was given information. It was written on the triangles. The other one that has 2 tick marks was the KM. So KM is congruent to NM. And again, why? That was given information. And then the one that has 3 tick marks was LM. And again, LM is in both of our triangles. Now that was not given information. I had to draw those 3 tick marks. So there are 2 things that we could say here. The first thing that we could say is that our line segment is congruent to self, right? That just basically means that, when you make the same line segment twice, it has to be congruent to itself. Or, and that's a lot of writing, what we could also say is that it is the reflexive property. That is also what we can say. So based on this information, side, 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 our two triangles, KLM and NLM, are now congruent based on side, side, side. Remember, once we prove that our triangles are congruent, remember, congruent triangles have all three sides in common and all three angles in common as well. All right, let's go ahead and try another one. So what about this one? We want to prove that these two triangles are the same. So again, I have my 5 triangle statements, congruency statements, and hypotenuse leg. Okay, so again, try pausing the video, trying to guess which one it's going to be based on some information. Okay, so if you thought about it, you paused it, you try to create your own flow chart, what you should have noticed is that this one was hypotenuse leg. And there were a couple of reasons why it was hypotenuse leg. First thing I see is that it's a right triangle. So ABC and DCB are both right triangles. I see 90 degrees, which tells us it's a right triangle, which means AC and BC are your hypotenuse, and all we need is a leg. And again, BC is our leg. It's what we add to it. Okay, so what's the first thing that I need to do? The first thing I need to do is figure out that it's a right triangle. So I'm actually going to say that triangle ABC and triangle DCB are right triangles. And that information is given. Okay. Now, what can I deduce from that? Well, I can deduce that AC is going to be congruent, right, to our BD. And again, that was given information. Okay. And I know that BC is congruent to CB. And again, I changed the letters, it's okay. But that was not given information. That is your reflexive property. Now, both of this is technically, think about this, this is like your H, your hypotenuse. This is like your L, leg, right? So again, these two pieces of information really did come from knowing that it was the right triangle, okay? And then last but not least, because it's hypotenuse, because it's a leg, these two are going to lead to our final conclusion, which is what we wanted. We wanted ABC to be congruent to DCB and Y, hypotenuse, leg. Again, once we know this, now all angles and all sides do match up. Okay, so we can prove triangles are congruent. We can also prove that sides or angles are also congruent. So in this problem, we are trying to prove that AB is congruent to BE, okay? So before we do this, before I can prove this, you must prove that our triangles, and we're going to say our triangles A, B, D, is congruent, right, to triangle E, B, C. That's what we need to prove first. So let's look at that first. Okay, so based on that information, I know that, again, side, 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 angle, side, angle, side, angle, 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 side, hypotenuse, leg. Oops, didn't need to put an extra L in there. Hypotenuse, leg. Okay, so let's see. Well, I know that angle B has some vertical angles, so I know that those match up. So I had to write that in there. But notice that these lines, AD and CE, have arrows on them, which means that they're parallel. So we can actually say that this is congruent to that because they're alternate interior angles. Again, what do I have? I have angle, angle, side, and angle, angle, side. So that seems like I should use angle, angle, side. Okay, so let's first prove our triangle. So we're first proving this. All right, so I'm going to start with my angle, or actually, it doesn't really matter. I'm going to start with this thing. The first piece of that was given to us. I'm going to start with BD. So BD was congruent to BE, and why do I get to say that? It was given information. All right, the second piece of information I wrote was angle B was congruent to angle B, but I don't really know which angle I'm talking about, so I want to use 3 letters. So I'm going to say that angle ABD is congruent to EBC. So remember, 3 letters, the letter that we want is in the middle. Now, I had to draw that in, so it was not given information. Its statement is vertical angles. Oops, I was going to write vertical twice. Vertical angles. Okay. So the last piece of information that we drew in was that angle A and angle E are congruent. Well, why did we say that? We said that because the side AD was parallel to EC. That was the first piece of information, and that was given. Parallel lines, if cut by a transversal, alternate interior angles are congruent. So now I get to say that angle E is congruent to angle A. And my reasoning? Alternate interior angles. So again, here's my angle, here's my angle, here's my side. So all 3 pieces of information lead to my conclusion that ABD is congruent to EBC. Once I get to say this, now all sides match up, now all angles match up, so this will lead to what I actually wanted to prove. I wanted to prove that AB was congruent to BE. And there's 2 things that we can write, okay? The first one, we can write it in symbols. We can say this, we can say congruent triangles have, right, little arrow, congruent parts. It's the first one that we can say. Or we can remember this acronym, CPCTC. Now you might be thinking to yourself, like, what does that stand for? So CPCTC, try saying that 5 times fast, stands for this: corresponding parts of congruent triangles are congruent. That's what that stands for. Again, C, P, C, T, C. So basically, what this is telling us is that this side matches up with this side once I've proven my triangles. That means also that this side matches up with that side. It also means that that lovely angle 1, 2, 3 matches up with this one, 1, 2, and 3. So we had corresponding parts because remember, they're in the same position. As long as they're in congruent triangles, we've proven it, then those parts are congruent. All right, let's try one more kind of similar to this. Okay, so go ahead and try to think why why potentially are triangles. So we must prove this first. So in order to prove angle B and angle D are congruent, prove, or not proof, say prove first that our triangle, and we're going to say triangle ABC is going to, so ABC is congruent to CDA. That's the first thing that we're going to try to prove. Again, think about our 5 statements that we have here that I keep writing down, okay, and see which one you come up with. Okay, so if you pause the video and you tried it on your own, hopefully what you came up with was that this was side angle side. All right, and the reason why it was side angle side is because I had a side given to us. BC and the line AD are parallel, which means that these are, oops, I've lost my pen. Ah, there we go. Came back. So this angle matches up with this angle right here because they're alternate interior angles. And then finally, this side, AC, is in both triangles. So that's why it's side angle side. So I'm first going to say that BC was congruent to our DA. And again, that was given information. Our angle C and angle A, again, I'm not sure which angle I'm talking about, but I was able to say that because first thing is first, BC was parallel to DA, so that's the first thing I needed to say. So that was given, and that led to angle. And again, want to be careful. I'm going to say BCA, and I'm going to say DAC. Why do I get to say that? I get to say alternate interior angles. So there's my side, there's my angle, and then my last side was AC. Oops. So what did I say? AC is congruent to CA, and that is your reflexive property. Okay, so these pieces of information, so 1, 2, 3, all lead to what we wanted to prove first. Triangle ABC congruent to CDA. Why? We get to say it's side angle side. And that piece of information leads us to what we actually wanted to prove. We wanted to prove that our triangle angles, B and D, were equal to each other. And I'm going to use the 5 letters, CPCTC. Corresponding parts of congruent triangles are congruent. Right? And that's how we organize our ideas into flowcharts.